the Sky This Month with your host, Dave McDonald.
Welcome to the Sky This Month. I'm your host, Dave McDonald, and this is March 2026, and boy, do we have an exciting month for you. Do you realize that there's not going to be another lunar eclipse that's total for 3 years? I'm going to tell you about when and where you can see it, but I hope you're catching this at the beginning of the month. We, of course, have the vernal or the spring equinox happening on March 20th, and the Artemis mission, as you know, has been rolled back into the vehicle assembly building with hopes to launch in April. We're going to be talking in detail about that. I'll be introducing to you, or reintroducing to you, Adam Krasnecki, who is an expert on all things Artemis. And we're going to start the show with this image. Do you see what we're looking at here? Now, I'm sure you recognize that to be a sequence of a total lunar eclipse. And this is going to be the last one for 3 years for us here in the eastern seaboard in the United States. 3 years before the next one, so you don't want to miss this one. How it works, you're familiar with the moon being on the other side of Earth. Earth is going to move between the sun and the moon, and that's what creates the shadow on the moon. So Earth is going to be moving in between the sun and the moon, and obviously the moon is a lot smaller, the sun is a lot bigger, and interestingly enough, the diameter of the sun is about 40 times the diameter of the moon, so it's going to work out real nicely. So that's how it works, and you want to get up early in the morning. We're talking about March 3rd, which is Tuesday, and totality is going to begin at 6:03. You need a really low, clear western horizon because it's going to be an eclipse at 6:03, but notice the moon sets at 6:21, so you don't even have 20 minutes to be able to see this if you can't see it right from a low, totally low, flat western horizon. And just before I forget, I think I said the sun is 40 times larger than the moon's diameter. It's 400. I forgot to add the 0. 400 times the moon's diameter. And so there you can see it. And Regulus is a star that is in the constellation of Leo, the lion, which we're going to be talking about a little later. And the full moon is going to be moving down towards the horizon by Regulus, and we're going to have a total lunar eclipse at 6:03, but the moon is set at 6:21. So try to scope out where you're going to get to go as soon as possible. And if you don't get this show until later, I'm sure there are places where you can look it up and watch it online. But it's so much better to be outside and watching the real thing as it happens. And as always, binoculars can be a help. Pi Day 3.14, that's March 14th, the national celebration, the irrational celebration of the brain, right? Because pi is an irrational number, meaning that you cannot write it as a fraction. And I don't know how many digits, millions of digits we have it, and it has not been repeating yet. And there are stacks, 500 or more sheets of paper with a 3 and a decimal point and just digit after digit after digit, 500 plus sheets of paper. It's an amazing number, and it's what makes the world go round. If we didn't have pi, boy, what would we do in astronomy? Could we figure out even how to get spacecraft orbiting Earth, to say nothing about us getting to other planets and getting to the sun, which we have, and we were in orbit around the sun, taking photos, keeping track of solar storms, and even the atom, nucleus, protons, neutrons, the circular orbits of electrons. Pi is so involved with this universe. It's really amazing, and it's kind of neat that we discovered it. So don't forget, March 14th, check out online and find some local celebrations of Pi. I know at the McAuliffe Shepherd Discovery Center, Pi Day is on a Saturday, and we'll be having some special Pi Day activities in Concord, New Hampshire at the McAuliffe Shepherd Discovery Center. Then we have the vernal equinox coming up, and that is going to be on a Friday, March 20th, 2026, obviously, at 10:46 a.m., and that is when the sun will cross the equator. And we will have March 20th at 10:46 a.m. Eastern Time. Notice that's 14:46 Greenwich Mean Time, or UTC time, or Zulu time. But the spring equinox is happening. Get your eggs out and see if you can balance your eggs on the end. So lots of fun happening there. Now, as we get into the Artemis 2 mission, I want to reintroduce to you our special guest today, Adam Krasnecki. Welcome to the show.
Pleasure to be back. Glad you keep inviting me back.
Yes, it's great having you here. And so the background to us is Stonehenge, and I just thought that would be kind of appropriate for the equinox. I'm not going to dwell on it. Sometimes we dwell on Stonehenge and such related to the equinox, but just makes a nice backdrop, and you can see the sun shining between the stones there. So this is just a reminder that March 20th, 10:46 a.m. is the equinox. The sun will be crossing the equator on its way north to the Tropic of Cancer, when we will have the summer solstice. Well, enough of that. So back to you, Adam. Tell us what's going on with Artemis 2. And I understand that unfortunately we didn't make the March window, and we're going to aim for April. But what's the mission all about?
Right, exactly. So any of you that are interested in space and astronomy, I'm sure you've been hearing rumblings about the Artemis missions for quite some time. What's brewing now is Artemis 2, which is going to be the first crewed mission. Artemis 1 was uncrewed, just a vehicle test. And now, as Dave said, there has been several launch windows that have been delayed due to various reasons. But now we're approaching the next one, and there's a lot of hope that it can be launched then, but also the ongoing concerns that it may not be. So hopefully that's something we get to see soon. I know a lot of people have been waiting. So this is a milestone for the space and astronomy community, as it's the first time humans have gone beyond low Earth orbit since Apollo 17 in 1972. So that's something that's really impressive, and is something that, if you think about it, how much we've improved in technology over the years and how we haven't exceeded low Earth orbit since then. It's really something that I feel like we should be doing more often, and I'm definitely excited to see it happen again. So this is using all NASA technology. This is the Orion spacecraft and the SLS. And an interesting fact is that it's launching from the Kennedy Space Center in the same complex that the Saturn V and the Apollo missions were launched from. So you can definitely see some similarities, and in the vehicle itself and the rocket with the solid boosters, you can see some similarities sort of to the space shuttle as well. Solid boosters are very similar models of the space shuttle, just slightly longer, and the engines in the rocket, the liquid fuel rockets, are actually the same exact engines as well, that they've been reusing some of the same parts of. Due to the fact that the space shuttle was a partially reusable vehicle, they have a lot of parts left over from that, and they worked well, and they serve the needs of this mission as well, although these ones will not be reusable.
And notice that the whole vehicle is sitting on top of the launch pad. Sometimes you may see, like in the news, they're talking about it's being on the crawler, being moved away from the launch pad to the vehicle assembly building. But the actual fact is, it's on the launch pad in the vehicle assembly building, and the whole thing crawls at something like 3/4 or maybe 1 mile an hour to get to the structure where the launch pad parks at the gantry and such. So technically, it's moving with and on the launch pad. And so as Adam says, it's got a lot of technical aspects, and it's nice to reuse, some things, some engines and such. And what you see to the right side there, that tank that looks like a water tank, it floods underneath when the rocket engines go off, the main engines go off, to quell the sound and the vibration and stuff. It just dumps, I think it's, 10,000 or more gallons of water get dumped real quick. And the items that you see to the right and to the left are lightning rods, because obviously you don't want your rocket getting struck by lightning. What else?
So just a little bit about the mission itself. It's going to be, like I said, the first crewed mission in this series. They will be launching into Earth orbit, and then they're going to do some maneuvers and testing of systems while they're near Earth. Something I thought was interesting about this path that they're going to be taking is they're going to be using some of the thrust of the rocket to get into a very eccentric orbit. So it's a very elliptical orbit with one side of it very close to Earth and one side much further away, out past geostationary orbit, where a lot of GPS satellites and the such are located. But the reason for this is that they'll be able to test some things at further distances and still have an easy way to bail, basically, on the mission. If something were to go wrong, they have just a waiting game until they're back close to Earth, and they can easily enter re-entry at that point. From there, they're going to burn towards the moon and do the translunar injection and fly around the moon with no landing. Something interesting about that is, due to the speeds involved with this orbit, they are going to be the furthest people ever in history away from the Earth. They're going to be further than the Apollo missions away from the moon, just due to the way that the speeds work out and how the gravity of the moon is going to help the craft return back to Earth. They're just going to be further away, and then they're going to set a new record for the furthest people from Earth, which is very cool. This method of using the moon's gravity to send the craft back to Earth is called a free return trajectory, and this is what saved the Apollo missions on Apollo 13 when they did have issues and they wanted to get back without using much thrust and power on the vehicle itself. They're going to do a high-speed re-entry splashdown in the Pacific, and as we know, there's 250,000 miles from Earth to the moon, so that's going to be quite the trip for these fellas.
Nice. And I love this slide here. So it's nicely numbered, and we can see the different steps of the mission from 1 to 12. And maybe, Adam, you could highlight some of the steps here.
Yeah, sure. So 1 obviously is liftoff, and then the first couple of numbers up until 5 or so are where I was describing. They're going to be doing some maneuvers closer to Earth, making sure that GPS and systems like that are working the way that they need them to be. And then after that, once they decide all systems are go, they're going to enter 6 and 7, which are the translunar injections, which is basically their path to the moon. 8's going to be the lunar flyby, and the gravity of the moon is going to help boost them back to Earth. 9 through 12 at that point. And like I said, it's basically a test flight mission. There was already a non-crewed flight with this setup with the Orion spacecraft and the launch system, and that one was just to make sure that everything would work getting into space. And now this is one focused more on the feasibility of humans being along for the ride.
And where it says number 8 there, that's on the far side of the moon, and what you were saying is when we're in that number 8 position, that we are going to have people farther than ever from Earth.
That's right.
Wow, that's crazy. And you think about, as you said, the moon is, an easy number to remember is 250,000 miles, and so to realize that people are that far away from Earth. And I remember it was Apollo 11, which was the first mission that landed on the moon. Remember, the Eagle has landed, Tranquility Base here. And Mike Collins was the astronaut that remained in the mothership, so to speak, in the spacecraft as it orbited the moon, while Neil and Buzz were down walking on the moon for a couple hours. And Mike Collins was asked once, when he was on the far side of the moon, he was by himself. Now, these people, there's going to be 4 of them in the capsule, so they can, they got work to do, but they can chit-chat with each other. But Mike Collins on Apollo 11 when he was on the far side of the moon in orbit around the moon, there was no human being in sight. Everybody was on the other side of the moon, all of Earth and Neil and Buzz. And so he was asked if he was scared or anxious or, overcome with loneliness or something like that. And I remember Mike Collins replying and saying, heck no. He says, I really enjoyed the peace and quiet because all the rest of the time I got NASA yakking in my ear and I got this thing to do and that thing to do. So I enjoyed it. It was roughly an hour of quiet I had every orbit. And he was quite a character. So, yeah, and then we're on our way back with number 10, 11, and 12 is Splashdown.
That's right. So, like I said, it's pretty much proving survival in deep space again after all these years, and with this new spacecraft, they're going to be evaluating the air pressure, long-duration survival, beyond GPS navigation, communications. I'm sure lots of those systems are much updated and far different than what they were during Apollo. They are going to have some manual control and some manual piloting during this mission as well, just as a test for if systems fail and other things that may need to be done along the way. And one of the most interesting things that I saw when I was researching about this is the effort spent on radiation protection as we go through the radiation belts of Earth, and how they have detectors for not only that, but also for potential solar flares, like as this system may be used in the future for future missions. Something undetected could happen and they may need to seek shelter. They actually have boxes in the module that they're going to be riding along in that they are basically used for storage, but they have a procedure set up as part of one of their emergency procedures that they can take everything out of those boxes and basically just barely fit 2 at a time in each of those boxes to hide and be sheltered from radiation. So that's something that's very interesting. I'm sure they have a counter on board. That's something they're going to monitor, and that's something that is interesting to think about, that I'm not sure much time was spent on the original Apollo missions thinking about that, where they were basically just in a race to get to the moon. But now this one, as far as going to the moon and potentially beyond, now they're thinking more about longevity of humans and keeping those things in check as well.
It's really crazy when you think about what has happened over the years, and it's been over 50 years since we've been back to the moon. And one thing that I find very interesting is, like, as you look at the cockpit of the Orion capsule here, and the Apollo capsule had a lot of instrumentation, a lot of buttons and switches. It wasn't a glass panel, so to speak, with computer screens like we have here. And one of the things that always amazed me, still does, is it was May 5th, 1961, when Alan Shepard went up on top of a ballistic missile, basically. They took a warhead off and put a human on. And Alan Shepard went up for the ride for about a 15-minute flight on May 5th, 1961. And it was July 20, 1969, 8 years and a couple months later, and we're walking on the moon. And we got back safely. And now it's been over 50 years, and we're trying to figure out how to do it again. And as Adam has shared, we're investigating things because we want to do it again. We want to do it better. And one of the underlying ideas is to maybe set up a colony on the moon. And at some point, maybe it's 100 years from now, send people to Mars. Adam, anything else you want to say about the cockpit?
I just basically had this photo on here to show how it has been somewhat modernized and looks more futuristic compared to all the pictures we've seen of the Apollo interior. But one thing I thought was pretty interesting is that they still kept a lot of analog buttons and dials as well. So maybe there's something to be said about the simplicity of doing that and not worrying about flipping through touchscreen menus while you're hurtling at outrageous speeds in the middle of space. So maybe some simplicity that's pretty cool to keep in that sense.
I know even when I'm sitting in a chair and I have my cell phone and I accidentally touch the wrong place, and
right.
who knows what happens, and that's not a good thing to happen.
Especially under the G-forces and the vibration that you experience under launch.
And you got a critical window to get back, to get to the moon, to get back to Earth, and then, to have an accurate splashdown. So Adam, why does this change everything?
Oh, this was sort of the same thing that Dave was just talking about, that really this is the stepping stone to landing back on the moon with astronauts. And in the bigger picture, it's going to be, like Dave said, establishing long-term lunar presence is one of the goals. And we're looking to build systems for Mars and pretty much just restarting deep space exploration. Some of the topics people have been talking about as well are the idea that with a launch vehicle like this, there can be the transportation of supplies to moon, potentially deal with less gravity and less atmosphere to launch again from there. Basically having a way to transport things to the moon and go and do science and things that we haven't been able to do in 50 plus years and get back on the map as far as deep space exploration is concerned.
Yeah, and it's been a while, and it's nice that we're back looking at getting these things under control, so to speak, again. And these things are very complex. So in my mind, delays are not unexpected, but hopefully we'll get things going and make it on time. So this is, do you know who this is?
I'm not sure exactly this astronaut, but the idea with me including this photo is that I hope everybody's ready to start seeing photos like this again and seeing our presence and leaving our mark on the moon, which we take for granted looking up at every day, but truly imagining that there's people on there right now as we think is something that would be really cool, and I can't wait to experience, because obviously I wasn't alive during the Apollo missions, but just thinking about that and having that level of perspective is something I think is really cool.
And another thing also is you see the suit and the backpack and stuff that they've engineered, the space suits and the moonwalking suits and helmet and backpack and their life support system, basically. And so I think you're going to see a difference in something that's more streamlined, more technologically advanced. So neat stuff. So, you want to introduce the people?
Sure. I wanted to put a little bit about the crew here. Something like I was just mentioning, the perspective of how interesting this is and how difficult it is to stay calm during it, is that NASA typically, their astronauts are people with a lot of experience in these areas. So you can see Reed Wiseman is a commander. He's former International Space Station astronaut. He spent 165 days in space, and he's a chief NASA astronaut. Victoria Glover, ISS crew as well, was previously a U.S. Navy pilot, F-18. Christina Koch, mission specialist, 328 days in space, part of the first all-female spacewalks that were had. And Jeremy Hansen, mission specialist, is actually joining us from the Canadian space program as well, was a former fighter pilot and a NASA mission control training missions, ran a lot of those as well. And something that's interesting too about the Artemis program is there's a lot of collaboration. I mentioned there's a Canadian astronaut aboard. There's a lot of sensors and technology from the ESA, the European Space Agency as well. So there is more collaboration than typical on a strictly NASA mission, but it's interesting, I think, to combine and everybody get a little bit out of it.
And it's neat when countries can work together. So that's about the people. Let's meet the people. And here's the crew.
Again, just really makes you appreciate how stressful the situations they're going to be in, navigating this to the moon and back, and their experience certainly plays into that, being able to stay calm in those high stress situations, basically working on end for days and days straight. Like, imagine the amount of stress that they're under and trying to sleep in zero gravity and be able to perform on all cylinders the next day and get stuff done. I couldn't imagine doing it. It's very impressive, and their background certainly suits them for the task.
Awesome. So that's kind of the basics of the Artemis 2 mission, which we hope is going to be taking place, liftoff sometime in April. And we look forward to keeping track of the spaceship. And it's going to be, what, Adam, about a 10-day mission?
Somewhere along those lines. Depends, I believe, on how much time they spend doing maneuvers in the orbit of Earth first, and then...
Because they intend to learn a lot.
Right, exactly. This is the first crewed mission. They want to test things out. There's a lot that they didn't get to test out the first time, and then there's still some differences with this mission as compared to the final mission, but they want to test as much as they can while still being the most safe as possible so that they have a lot of exit routes and make sure that they set themselves up for success.
That's the name of the game, success. Well, Adam, thanks so much for being part of our show again, and thanks for all the research you did and the wealth of knowledge that you have shared with us today.
Pleasure being here. Thank you.
You're welcome. And in just a moment, we'll be taking a look at the night sky and seeing what can you see in the night sky. I got a couple of special objects for you. Well, I hope you enjoyed that chat with Adam about the Artemis missions. Keep abreast of what it's doing and when it's doing, and it's going to be a great, great trip. So we're looking at the sky. I chose March 20th around 8:30 in the evening here. And obviously you see all this artwork here, which is unrealistic when you look at the slide at the sky. But I wanted to just illustrate the zodiac signs, because you know that spring is coming in like a lion, and winter is going out like a lamb. Well, so far, not so. It's not going out like a lamb yet, but we have time. We got a whole month of March, and maybe, you know, the weather will change a little bit. But I thought this would be interesting because as you look at your screen, to the right is towards the west. We're kind of facing south, and this happens to be March 20th, but the sky is pretty much the same. It changes 4 minutes from night to night. And so this is Aries the ram, just off the screen to the lower right. And then we have Taurus the bull, right along the ecliptic, the zodiac. And then we have Gemini, the twins, with the twin stars, Castor and Pollux. This bright object here, that's not the moon, that's Jupiter. Jupiter is nicely placed in the constellation of Gemini for the month, and it is really bright. The only thing brighter will be the moon if it's in the sky. And Venus is rising after sunset, so Venus will be getting into the act, and it shines brighter than Jupiter does. And then we have Cancer the crab. I'm going to show you something neat about Cancer the crab, and then Leo the lion. Awesome. And the great star Regulus, and remember, that's the star that the moon is going to be sliding by on the morning, as you look west, but in the morning of March 3rd, the moon is going to be hanging out near Regulus for the total lunar eclipse. So let's look at the next slide here. And I have the lines here because I wanted to point out where you can find the object that I'm talking about. So this is basically the same sky minus the artwork. Now we're going to add some lines to help us. And here is Castor and Pollux, the twin stars, and the planet Jupiter. And then Leo the lion, with easily to find because it looks like a backwards question mark, you see, in the sky. And so this backwards question mark with Regulus, kind of the dot under the question mark, if you will, representing the head of Leo the lion. And pretty much in between Regulus and Jupiter, and it's almost exact, between Jupiter and Regulus is the beehive star cluster known as M44, or the Praesepe. And so Cancer itself is a fairly faint constellation, but if it's really dark and the moon's not in the area, you should be able to detect a little fuzzy spot there, because the ancients did, and they called it the Praesepe, the manger. So if you have binoculars, that'll help a lot, because there is 1,000 stars there, and if you had binoculars, you could probably, if you wanted to count 100 or 200 of them, it's about 600 light years away. this star cluster is. Let's take a closer look at what it looks like. This is M44, the Praesepe, which means manger, or the beehive cluster. And it's got the nickname after we had telescopes to be able to look at it, because it looks like a bunch of busy bees. So it earned the nickname the beehive cluster, though officially thousands of years ago it was the Praesepe, or the manger. There's a whole biblical Christmas story in the constellations of the skies, and this was part of that. So very beautiful. Binoculars, a small telescope, is just really awesome. And then next, without the lines or the artwork, can you find things? Well, Orion, the hunter, is easy to find. And again, we're facing south, and this is towards the west. So off to the right of your screen, we're talking towards the west. And so you see Orion, the hunter here. Sirius, the brightest star. It's not as bright as Jupiter, right? Jupiter is probably 5 times brighter than the star Sirius, which is the brightest star in the night sky. And that's the big dog star. And then Procyon is the little dog star. So those are still some things you can be looking at towards the west, facing south, but towards the west of the sky. So I hope that you enjoyed the tour of the sky. I hope that you enjoyed our chat about Artemis. Don't forget the equinox happening on March 20th at 10:46. Don't forget Pi Day, March 14th. Don't miss it. And please don't miss that lunar eclipse. Early morning, 6 o'clock. Start looking before 6 o'clock on Tuesday, March 3rd, towards the west. And as the moon is in totality, it will be setting, so don't miss it. And then lastly, keep an eye on the Artemis mission for hopefully a launch in April. So that's the show. I'm Dave McDonald for The Sky This Month. And don't forget to keep looking up.